Is recording started? Yes. Okay, so today we're looking into the rotational equilibrium. Today we're learning the 10.
Hello, YouTube channel. Like and subscribe.
Rotational equilibrium. Now, let's consider, for example, this ruler. Is the forces, which forces acting on this ruler now?
Gravity.
You have gravity down, and
your hand up,
and the normal reaction from my hand up. Got those forces opposite in direction equal, it is an equilibrium. But, so it's not moving up or down, but it can rotate, as you can see. Is the net force still zero?
Yes.
Yes. So, for something to be completely stationary, not just not moving, but not rotating, we need one more condition on top of the net force equals zero.
leverage.
So, to explain this condition, we need to introduce the new physics quantity. It's called torque.
Torque.
That's a never.
Which is denoted with the Greek letter tau.
Is this like TikTok? That was amazing.
Like you can be part of this, you can.
Yeah, maybe I actually I might know this.
It will go. It will be on YouTube. So, torque.
That's going in like.
The physics quantity, torque. We denote it with the Greek letter tau. And it's equal, we can use two formulas to describe it. A, the perpendicular force times lever arm, or force times perpendicular component of the lever arm. To understand what is it,
Is that an R?
this is R, yes. So we have,
It's confusing me already.
and let's say this distance is R. And that distance we have force applying vertically down. In this case we have that the force is at the right angle to the lever arm. And in this case torque will be equal just force times lever arm. Just force times the distance of the pivotal point, the point around which rotation can happen, and in which direction will this force try to rotate this beam.
Wait,
We have two ways, clockwise or anti-clockwise. What will be this direction?
Clockwise.
So, for this ruler not to rotate, what should happen?
Same force on the other side.
Not force, torque.
Torque.
Same torque on other side. So we need to have, if this is the same R,
Then it's the same
same
force.
F, we will have torque clockwise equal torque anti-clockwise. So if we have, so two conditions for object not moving completely, not changing its position in space, not rotating. We need to have net force be 0, and we have net torque which is a sum of the all torques rotating clockwise and anti-clockwise.
Is that to have rotational equilibrium?
That is rotational equilibrium. When object not moving, it's not rotating. So torques rotating clockwise must be equal torques rotating anti-clockwise. Does that make sense?
Yeah.
Where is torque measured? In the middle of the two arms, or?
Torque is here, applied. It's not applied here.
It's not applied there.
It's applied here, at this point,
okay.
at this point.
And at the other point.
And at the other point. What will be the unit of the measurement of the torque? Newtons? Meters. So unit for measurement of the torque, there is no special unit. It's measured in Newton times meter. Torques measured in newtons times meter. Let's consider a simple example. Let's consider a simple example. We have a seesaw, and on one end we have a person with a mass.
What do you mean? What do you mean?
Person with a mass, let's say 60 kilograms, and one and R2,
I don't know why I was saying.
R1, the lever arm, equal, let's say 1.5 meter, or 2 meters. 2 meters. Question is, what should be, we have this is M1G,
120.
and we have another person
You're wrong.
with a mass M2 equal 80 kilograms.
Oh, that's Zach.
And what should be distance from the pivotal point that that person sits to have this system in the equilibrium? What the torque rotating clockwise?
Ah, that's interesting.
Torque rotating
1.5.
clockwise equals, let's take, to make it more simple, let's take G equals 10 for calculations for now. So what will be this force equal?
120.
120. No, force.
600.
Force will be 600 newtons.
Where? Oh, because
mg.
Yeah. 600.
We'll have a force equal 600 times lever arm times 2 equal 1200.
Get it? Because it's not 10. It's
Now,
No.
for this to be, because person has mass 60 kilograms, mg equal 60 times 10, 600, times lever arm, 2, torque 1200.
torque anti-clockwise.
Now, to be in the equilibrium, torque anti-clockwise has to be the same.
Yes.
So we should have that m2g times lever arm 2 has to be equal same 1200. So we have 880 kilogram times 10, R2 equals 1200. From here, what will be R2
1.5.
equal? We divide on both sides.
No, but that doesn't make
800 will be
sense.
1.5 meters.
It doesn't make sense because
That's the whole point.
Why?
what if the R2 is like a negative?
F net's not zero.
Distance negative?
Yeah, what if it becomes negative? Because the
If everything is positive, how will this can become negative?
But doesn't F net need to be zero?
oh yeah, no mind.
F net will be zero. Excellent. Yeah, this person heavier, so need to see. This person 60 kilogram at 2 meters. This person 80 kilogram will be at 1.5 meters.
And will it always make sense? Like, of course.
Is F net zero because of the
Now,
normal?
F net. Which forces, when we're talking about net force, we consider the total forces acting on this beam.
Just on the
Which force is acting down?
Gravity.
We will have M1G plus M2G.
But shouldn't they equal?
What else acting on it?
Normal.
Normal reaction at the pivotal point. And that normal reaction will be equal 600 plus 800. Normal reaction will be equal 1400 newtons up. And both conditions are satisfied. Net force equal 0. We have 1400 newtons down. We have 1400 newtons up. And torque clockwise equal torque anti-clockwise. Make sense? Now, but what if force acting not at the right angle to lever arm? Now consider this rule. If I will be, let's say this is a point around which rotation can happen. If I will apply force along this beam line, along, I will push in this way. Will it create any rotation? If my force acts in this way? No. No.
What?
Already.
Yeah. Okay, we will continue.
Time flies when you're having fun.
We will continue next lesson. Now, please, as a homework, please, no questions because we have not done much. Please read from your textbook. From your textbook, please read
I will do the
10.8 and 10.9.
Your brother's key.
yeah.